Realize I said I'm going to make a new video, but it's actually a very small topic, so I could have just done it. Anyway, here we go. Which is the following, which is true regarding pressure? So let's have a look at the different options. Pressure, vector quantity. No, pressure is just a scalar. It acts in all directions. It doesn't matter. It acts parallel to the surface. No, it doesn't, because if I had the surface here, and if I'm applying a pressure down, this is not parallel. This is perpendicular. That's perpendicular to the surface. That's wrong. Equal in all directions in fluids? Yes, if I had like a bubble or if I had some water, it will apply in all directions. And that's why bubbles are round, by the way. Fun fact. Measured in newtons per meter. Pressure is F over A, so that would be newtons per area is meter squared. So that's wrong as well. So the best answer is C. Why have I got a blue pen? Let's get back to red. Good old red marking pen. This is a good teacher's pen. The diagram shows 4 solid pieces of the same metal, so it'll be the same density, same thickness, stands on the same, okay. Which has the greatest pressure? Okay. Greatest pressure usually means smallest area or bigger force. A bigger force, directly proportional. Smaller area, inversely proportional. You can see I'm dividing by A. Makes sense. If you had a pin and you were to try to touch the pin with your finger on this side or the finger on this side, you can guess which side's going to hurt more, right? It's going to be the one with the pin because it's got smaller area, bigger pressure. That's the idea. So smallest area would be A or C. But I see this is bigger. Bigger means more force, which means heavier. I will pick A. If I asked you for the least pressure, you're looking for the bit, maybe this one, B, or D instead, because they have a bigger area. Least pressure, this D would have been better because this has a smaller size than B. This will be less force acting on it. So this would have the lowest pressure. But I didn't ask for that. It asked for the greatest, so it would be A. Okay, which suffered the smallest? Okay, smallest pressure. Okay, let's go. Now, smallest pressure is the biggest area. It's going to be the same block no matter which way you put it. It's the same block, so I can put it on P, Q, or R. These are the 3 choices that I currently have. So, of course, the pressure will not be the same. It's not any of them because it depends on how much it's, what area it's acting on. So, if you know a bit of math, you can realize that the biggest area, without even calculating, has to be P. 80 by 40. It has to be P. Q will be the smallest area, biggest pressure. R is in between. So the best answer here is P. So nitrogen gas at this volume is compressed. Very nice. And we need to figure out the new volume. So this looks like the gas laws. The general equation, the combined gas law, is PV over T equals PV over T. If you don't know which one to use, you can use this one. And you can see, look, the temperature is constant. So temperature is cancelled already. Don't need it. All we have is P1V1 would be P2V2. That's supposed to be a P to start with. P2V2. So I'll use that. I'm cancelling the temperatures because I don't need it. Now I just need to figure out which one's which. I normally like to write it like this. P1 equals, V1 equals, P2 equals, V2 equals. That's not squared, that's a 2. Gas has a volume of this at a pressure of this. Nice and easy. So 10, 1, 2, 3, 0.022. That's the volume one. Is compressed, and the new pressure is 9,000. And clearly it's asking me for my new volume. That makes it easier for me to see where I'm putting the numbers. 10,000, 1, 2, 3, multiply by 0.022 equals 9,000 times V2. Okay, shift solving it, you'll get your answer. Hopefully you'll get 0.024, and that'll be in meters cubed. Volume is measured in meters cubed, or liters you could use. And now, does that make sense? Let's see. The new pressure has decreased. If the new pressure has decreased, that means my volume should have increased. And let's see, my volume started with 22 and it increased to 24. That makes sense. Bigger volume means less pressure. Very nice. Let's go on to the next one. The temperature of a gas cylinder is increased at a constant pressure. What can you say about its volume? Oh, great. I've just talked about that. Well, this is a slightly different one. This is about temperature now. Increasing the temperature means the particles will move faster and hit the walls harder, and then that will make the walls expand more. So the volume will increase. If it gets hotter, more energy, spreading them out a little bit more. Something talks about the gas, sample of gas varies directly with its temperature. So what we're talking about, volume and temperature. Volume and temperature is simply Charles's law. Archimedes' principle was cancelled, which is nice. We don't need to know it. Law of flotation. Pascal's principle was also... No, it's not cancelled, actually. That's coming. That's to do with force over area and stuff. Boyle's law is the other one. What's that again? I think that's the PV formula. Very good. Okay. Let's see what's next. Now we have a volume. Liters is okay. Temperature, 20 Celsius. Okay. And then we have this volume and this new temperature. Great. So I'm going to put this into Kelvin. So what am I going to do with this? Did I put the previous one into Kelvin? Oh, I didn't need to because there wasn't a temperature. Yes, so temperature, let's put this into Kelvin. So this will be simply 20 plus 273, which will be 293. Amazing math. Okay, now I need to know the new temperature. So V and T. If I was to use PV over T, PV over T, I can see it's constant pressure, so P cancels. Is V1 over T1 equals V2 over T2. I need the new temperature, which is T2. So I'm just going to put the numbers in because I don't want this to get too long. A gas of an initial volume, so that would have been 6 over at the first temperature, which was 293, equals my new temperature I need to find, but I have a new volume, that's 4. So if I was to go ahead and solve that, I would get T2 equals 195.3 Kelvin. Great. It didn't specify if I should have it in Kelvin or Celsius, but because they gave it to us originally in Celsius, maybe it's a good idea to bring it back into Celsius. So if I wanted to do that, I will do T2 in Celsius is simply 195.3 minus 273. We're working backwards. If you don't do this conversion, your answer will be wrong. So you make sure that you definitely do the conversion. So 195.3 minus 273 minus 77.7 degrees Celsius. Kelvin doesn't have a degree on it, but Celsius does. Okay, what is true about this? So this is talking about pressure inside the liquid. Actually, the pressure in the liquid is the same everywhere. That's how I can move this small area and get this one up. So the pressure is exactly the same because P equals F over A. F over A. P over here is F over A. P equals P. Very good. What am I doing here? Greater, 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 all the same. D is the best answer over here. Okay, let's move on. So find the pressure applied on this one. So we want to find the pressure by piston K. Piston K is here. So we have this area and we have this. Very nice. So what we're going to do is do P equals F over A. AT over, centimeters, not good. So 40 centimeters squared. If you want to put that into meters squared, actually this will end up being times 10, not to the minus 2, not divided by 100, because it's times 10 to the minus 2 squared. It's times 10 to the minus 2, and then we're squaring it. So that becomes, in total, times 10 to the minus 4. What did I just do there? Centimeter squared into meter squared. Centimeters is divided by 100, which is minus 2, but it's squared, so I have the power here. So that means minus 2 times 2 becomes minus 4. So that becomes 40 times 10 to the minus 4. That's what you need to do for this one. Be careful with this. Centimeter squared is minus 4. Millimeter squared will be minus 6, and so on, and so on. But centimeter squared, minus 4. Meters squared, obviously, is fine. Putting that in your calculator, you'll get 20,000 pascals. Very good. Next, find the upwards force on the next piston over here. Finding the force here. So we have a starting force, we have an area, we have an area, we have another force. Okay, so we'll do the F over A equals F over A. You could use this pressure over here instead and then solve it. It doesn't matter. I'm just going to do it this way because it's a little bit different. So I have AT over 40 times 10 to the minus 4 equals, I need F2, equals, and what's this? Area is 2, also centimeters, so that's basically going to be times 10 to the minus 4 as well. F2 will end up becoming, hopefully, 4 newtons. Very nice. And we have the last page to do. Nice. Okay, what do we have here? The force on the small piston of hydraulic lift is this, and the area is that. What is the force exerted by the other one? So I'm just going to go ahead and do the same thing. F over A, F2 over A2. Okay, what do we have? So we have force 1. Okay, so I'll write 750 divided by the area of the smaller piston. Meter squared is good. Okay, so small piston, small area, which has that force, 0.0075 equals, I need to know the new force, and the new area is 0.13, also meter squared. F2, we will solve it, and hopefully we will get, let's see, 13000. 1, 2, this is good, you can do that, or you can write, what's the unit? Newtons, very good. So this will be 13,000 newtons. What statement about the pressure of point P, Q, and R is correct? Okay, so what are we asking for? But this is talking about the pressure. Okay, this is inside a liquid now. Inside a liquid, it's not about this area, it doesn't matter. The liquid varies with depth. You are thinking about how much water is directly above you. Don't care about the water on the sides, just the water directly above you. Don't care about the sides, only with the water directly above you. It's rho GH. Pressure equals lazy P, rho looks the same, that's a capital P, GH. Varies with height. So it is the same in all of them. Doesn't matter about the shapes. If I had a triangle, a backward triangle, or a square, and I filled it with water, as long as the height is the same, they will all have the same pressure. Very good. Thank you very much.